Hello, this is Mr. Collier, and today we're doing the area under a curve and between two curves. So in the first example, we've got f of x equals negative x squared. So let's check it out. You should always consider what the graph looks like. And this is negative x squared, so it's down here below the x-axis. Okay, and it's going from x equals 0 to x equals 2. So let's say 2 is about there somewhere. And there's 0. So we're talking about this little area right there. Okay, that little tiny area. Notice this is under the x-axis, so if you just do the integral, you're going to get a negative number. So the area is going to be, there's two ways you write it. You can write an absolute value sign. Okay, you can do an absolute value of the integral from 0 to 2 of negative x squared dx. Or since it's all negative, you can just multiply it by negative 1. So you can write it like this, right? Writing it that way, you can actually see that it's the same as integral from 0 to 2 of x squared, which totally makes sense. It's the same thing as underneath the curve of y equals x squared, right? So that's going to give you, if you integrate, you're going to get 1/3 x cubed. I should have put that cubed here. Evaluated from 0 to 2, so that's just 1/3 2 cubed minus 1 cubed, and that gives you 2 cubed, so that's 0 cubed, sorry. So it's 8/3 exactly. All right, the next example, again, we need to know what the picture looks like. So this is negative x squared plus 4, so it looks like that. Negative x squared plus 4, and between x equals negative 1 and x equals 2. Well, we know the x-intercepts are going to be 2 and negative 2. So we're just talking about right here, this area. Okay. Actually, this is 2 right there, so we're talking about all this area right there. So the area equals the integral from negative 1 to 2 of negative x squared plus 4 dx. Okay, so that's negative 1/3 x cubed plus 4x evaluated from negative 1 to 2. That is negative 8/3 plus 8 minus all of this with negative 1 substituted in. So that's 1/3 minus 4. Okay, and then we could do the negative 8/3 minus 1/3 is negative 9/3. Okay, that's negative 9/3 plus 12, so that's like 12 minus 3, which equals 9. Okay, you can also get the area between a curve and the y-axis. It's the same thing as doing it with the x-axis, so if you're going to do a function of y and you're going to do a dy. Okay, so this is already written as a function of y, sometimes you have to do that yourselves. So this is like, I guess you could say this is the top part of the function right there. Okay, so when you integrate, this is going to give you a positive area when you integrate this above the y-axis, or to the right of the y-axis. Okay, so actually this kind of doesn't quite match the picture, but this is from negative 1, so let's see what the graph looks like of this. So let's see what the graph looks like. The graph of that, x equals root y, okay. The graph of that from negative 1, y equals negative 1 to 4, well, this is going to be, if you plug in negative 5, you're going to get 0, so actually it starts at negative 5 and goes like that. Okay, so we're talking about this area from negative 1 all the way up to 4. Okay, so we're going to integrate the area equals the integral from negative 1 to 4 of y plus 5 to the power of half dy. Okay, so we can increase the exponent by 1 and divide by 3 over 2, gives you 2/3. And we want to evaluate that from negative 1 to 4. So it's 2/3 times, and this is going to be 9 to the power of 3 over 2 plus 5 minus -1 plus 5 is 4. 4 to the power of 3 over 2 plus 5. Okay, so that gives you, let's go up here, don't have much room. 9 to the power of 3 over 2 is like square root of 9 cubed, so that's 27. Okay, 27 plus 5. And actually going to have a minus 5, so that's going to cancel out. But 4 to the power of 3 over 2, that's square root of 4 cubed is 8. So that's going to be minus 8. Let's get that, let's erase that. Minus 8, and then minus 5. So the 5's cancel, and that is 27 minus 8 is 19. 19 times 2 is 38, so it's 38/3. Okay, next, between two curves, we can simply subtract the two areas, okay? So like over here, if you want to get this black area, you can get the area underneath g of x, and then subtract the area under f of x, and you get this black area, right? It's just like normal subtracting when you have overlapping areas, right? And this here will give you a negative number, negative area. So when you subtract it, it becomes positive, so you're like adding it on. So that's why you don't have to worry about negatives. When you subtract a negative, it becomes positive. So if you do top function, it's always top function minus bottom function. And the negatives will automatically cancel out and give you positive. Okay, so determine the area bounded by these graphs. So we need to know what it looks like first of all. Y equals x looks like this. It's a straight line. Y equals x squared looks like, let me draw that a bit better. Like that. So the area we're talking about is there. They intersect at 1, 1, and starts at 0, 0, obviously. So the area is the integral from 0 to 1 of top function minus the bottom function. And that is half x squared minus 1/3 x cubed, evaluated from 0 to 1. Zeros will cancel, so just sub in 1. You get a half minus a third, which is 1/6. Okay, in the next example, we've got, well, we need to graph it to determine what it looks like, and you can actually factor them both to figure out where the x-intercepts are, and then we can graph it. So we have, this is going to be at 2 and 4, and this is a parabola facing up. And this one's at 0 and 4, and it's facing down because there's a negative in front of x squared. So that's, let me do that in a different color. 0 and 4, upside down. So actually we're talking about this area, and that kind of matches this picture up here. Okay, so the area is equal to, and we need to find the point of intersection right there. Okay, so let's do that actually first. The point of intersection, we just set them equal to each other. Okay, so that's 0 equals 2x squared minus 10x plus 8. We can divide by 2. We got x squared minus 5x plus 4, x minus 4, x minus 1. So it intersects at, obviously at 4 and also at 1. Okay, so that coordinates there is, well, the x value is 1. Maybe we only need the x value, because now we know we need to integrate from 1, starting spot, to this spot 4, top function minus bottom function. Top function is the red one, which is the upside down one. It's 4x minus x squared minus the bottom function. Okay, and let me show you now how to do that on the HP Prime calculator. Okay, this is on a paper 2 test, a calculator test. You just want to type that in. So you can click on this button and get the integral, and from 1 to 4, and just type it in exactly as you see it. Don't need to simplify. Just be careful not to make a typo. Oops, I made a mistake there. Put in a subtract and brackets, and just type in the function exactly as we see it. No need to simplify. Okay, so I click on that, and it gives you exactly 4, exactly 9. It is exactly 9. I'm in the Finance app, so it likes to round to the nearest 10th. Let me get out of the Finance app. Okay, exactly 9 is the answer. Okay, let's look at some more. And maybe we'll just do a couple more. Let's do this one right here. Okay, let's take a look at this one. So we've got root x looks like this, and negative x plus 6 is like a y-intercept of 6, and it's a line going down with a slope of 1. So the area and the line y equals 1. Okay, y equals 1 is here. So we're talking about this little area here. Now if you do it with respect to x, you have to split it into two parts because the top function changes from here to here, right? But if you do it with respect to y, then you don't need to do that. So we're going to do that in a bit. Actually, first, either way, you need to find the point of intersection. So let's do that first. Point of intersection. Okay, so you set them equal to each other. And then square both sides. You're going to have x equals x squared minus 12x plus 36. 0 equals x squared minus 13x plus 36. Factor that. You get x equals 4 and x equals 9. Because this is a square root equation, this one's extraneous. This is obviously going to be at 4, comma, and if we sub in 4, you can sub into either one, but obviously it's going to be 4, 2 if you look at the square root equation. So that point of intersection is 4, 2. That means we can do, and the intersections here are 1. The x value is 1. And over here, the x value, if you sub in 1 here, you get 5. So this is 5, comma 1. So this means the area is equal to the integral from 1 to 4 of root x minus 1, because from 1 to 4, root x is on top. And then from 4 to 5, the other function is on top. So you got to add these two areas together. So this is, oops. Is that right? Oh, yes, that's right. So that's negative x plus 6 minus 1, because y equals 1 is the bottom function. Okay, and if you go through all the algebra, or if you use your calculator, you'll get 13 out of 6 for that. Okay? But it's easier if you notice, if you think about it with respect to y, then the top function is the same the whole way, or the rightmost function is the same the whole way. The line is above the root function the whole way. So we can do this if we have a function of y. So x equals y squared. If we solve this for x, we have x equals 6 minus y. Okay, so we're doing the same integral, but now we can go from the y values here, go from 1 to 2. So we can do the integral from 1 to 2. And the top function, if you will, is the line in this case. So that's 6 minus y, and this is y squared. So you can do this integral. Okay, and you can do it by hand or use the calculator. You'll see you also get 13 out of 6 for this one. But the setup is a lot easier. Okay. Okay, next, compound area. So let's check out this one. This one, we have two parabolas. So let's take a look at what the function looks like. X plus 2 squared means we're over here at negative 2 is the vertex. And then this is y equals x squared. Looks like this. I did not draw it very well, but this is This area here is going to be like symmetric. So one thing you can do is you can do twice the integral from -1 to 0, okay, of just underneath the green function, which is x squared. Okay, you can split into two different integrals there, but this is the easy way to do it, to recognize the symmetry of the graph and integrate this. So we have 2 times 1/3, and this is x cubed from -1 to 0. So that's like 2/3, and we sub in 0 minus -1 cubed. And that's just going to give you +1 times 2/3, so the area is actually 2/3.